My name is Zachariah. I'm with Void Loop, and today I'm introducing our new cross-platform desktop application, ViewPoint. ViewPoint is a real-time visualization and interaction platform for embedded systems that bridges the gap between simple serial plotting tools and lab-grade instrumentation. I'll start by selecting a serial port and connecting to the Teensy 4.1. ViewPoint ships with a firmware library for the Arduino ecosystem with example support for many Arduino compatible boards, including the Teensy, Raspberry Pi Pico, and ESP32. This sketch samples the onboard analog-to-digital converter at 800 kilosamples per second with 150 kHz of visible bandwidth. The microcontroller sends both data and plot configuration commands, so the visualization is self-describing. Here there are two Cartesian plots, the top plot showing the time domain waveform and the bottom plot showing the frequency domain view. The Teensy is connected to a signal generator, and as I adjust the input, ViewPoint updates both plots immediately. This makes it easy to inspect waveform shape, amplitude, frequency content, and behavior over time while the firmware is running. Now I'll do a quick pass through the main panel, starting with the controls panel. The controls panel exposes runtime configuration for the active sketch, including individual plot and trace settings. Here you can adjust trace labels, trace colors, visibility, and more. And here we can adjust per axis labels, scaling, bounds, ticks, as well as activate display modes. These settings can be driven from the UI or from the serial command screen. Before activating a display mode, I'm going to use my signal generator to generate a sweep. There we go. Now I'll activate persistence on the lower plot. Persistence accumulates and fades repeated frames in a phosphor style view. Spectrogram shows frequency content over time as a waterfall view with selectable color maps and decimation controls. Gradient builds a digital intensity map with configurable decay highlighting transients and where signal activity occurs most often over time. Next up is the analysis panel. The analysis panel is for inspecting data more closely, including markers, cursor-based measurements, peaks, harmonics, reference lines, and live trace statistics. Here I'll add a marker, select a peak, and turn on peak locking. And then if I adjust the input waveform, the marker follows the peak. I can also transition to a square wave and jump between peaks, like so. If I adjust the threshold, I can choose which peaks are selected. And there's also delta markers, harmonic selection, and spanning markers, which span multiple plots. When I'm ready to save my results, ViewPoint also includes capture tools for saving CSV data, screenshots, and screen recordings, which are useful for debugging, documentation, and comparing test runs. That's a quick introduction to ViewPoint. Thank you so much for watching. Please join us on the forum to ask questions, share projects, and help build community. We also have hardware products shipping soon, so there's a lot more coming.